Okay, so I wanted to just briefly talk about the FOIL method versus the area model when multiplying polynomials. So when I was in school, I was taught the FOIL method, and if you're unfamiliar with the FOIL method, FOIL just stands for first, outside, inside, last. In other words, when you're multiplying a pair of binomials like this, you multiply your first terms, your outside terms, your inside terms, and your last terms, essentially the distributive property. Now, this is something that's very commonly taught, and when you're dealing specifically with a pair of binomials, it can work well. So for this one, I'll just do it out quickly using the FOIL method. So multiply my first terms. So 3x times 5x, get 15x squared. 3x times 4, those are my outside terms, plus 12x. My inside terms, minus 10x. And my last terms, I get a minus 8. Combine my like terms, and I get 15x squared plus 12x, plus 2x, fix that, minus 8. So, fairly straightforward method. But the problem arises when we're dealing with anything other than a binomial times a binomial. For example, if we alter this, and all of a sudden it's a binomial times a trinomial, then we have a bit of a problem because we no longer have just 4 terms, right? The FOIL method relies on us having first, outside, initial, last. Well, I've got first, I've got outside, but then I have this kind of extra middle term. So that's not going to work, right? We can't, and we could kind of extend the FOIL method and say, hey, let's draw out, all right, distribute each part. But the further we go, the more messy this gets. And it can be hard to track those lines, and our goal is to be as organized as possible. So I like to use what's called the area model. Now, the area model relies on a pretty basic concept, and that concept is we can represent the multiplication of two terms, any two terms, with the area of a rectangle. So imagine I'm multiplying just two regular old numbers. Maybe I'm doing 37 times 59. This is something that you can punch it into the calculator, find an answer, but it's going to be maybe a little tricky to just do in your head right away. So what we can do is we can recognize, all right, well, I'm multiplying two terms, and multiplying two things, well, the area of a rectangle is always just length times width. So I'm just going to say 37 is length, 59 is width. Except I'm going to break up my tens and my ones place. So 37, 59. And I'm going to multiply each intersecting area. and I'm going to find the sum of my smaller areas. And whatever that sum is going to be equal to the total area. So let's go ahead and do that. So 50 times 30, we can do that pretty easily. It's 1,500. Then we've got 50 times 7. That's just 350. 9 times 30. It's going to be 270. And 7 times 9, 63. Then we can just add these up. Let's see, 1,500 plus 350. 1,850 plus 270 is 2,120 plus 63. We get 2,183. And if I use my calculator to check, then all right, looks like we got it. And that's just with plain old integers. Now we're going to go ahead and extend that method to actual polynomials because it works the same way. All we need to worry about is having two terms being multiplied. And right here, the fact is we do. We've got 3x minus 2. I'm going to mark that as our length. 5x squared plus 4x minus 7. I'm going to mark that as my width. Oops. Myself a little bit more space here. Add that up. Okay. And the size of the rectangle is pretty arbitrary. You can make it however you want. All right, so I'm going to say 3x minus 2. I'm going to split my box right there. I'm going to be multiplying those separately. Then I'm going to say, all right, I've got 5x squared, positive 4x. I'm going to keep our sign with each term, and negative 7. I've got 3 parts there. Go ahead and section it off. Okay, so let's just multiply each intersecting part. 5x squared times 3x, it's 15x cubed. 5x squared times negative 2, that's negative 10x squared. 4x times 3x is 12x squared. And 4x times negative 2 is negative 8x. Negative 7 times 3x, negative 21x. And negative 7 times negative 2 is positive 14. Now, the awesome thing with using the area model when you're multiplying these polynomials is my like terms are always diagonal from one another. So there's my squared terms. There's my x terms. I'm going to just go ahead and write this out. So 15x cubed. There's nothing diagonal from it, at least from bottom left to upper right. So that is just going to stay on its own. 15x cubed. Then we've got to combine 12x squared and negative 10x. It's just negative 10x squared, sorry. That's 2x squared. Combine negative 8x and negative 21x. I get negative 29x. And then 14. There's nothing bottom left to upper right to combine it with. So we just get plus 14. A little bit. And that's pretty much how you do it. So this is a method that I really like because no matter how many terms, no matter how many monomial terms each polynomial has, you can still make an area model to represent it, which you can't do with the FOIL method. And the FOIL method, while it's a fun acronym, it only applies to a binomial times a binomial. Area applies to a much wider range of all polynomials. All right, hope you found that helpful.